So this is the third lecture for our topic motion in a plane. Let's quickly go through the topics that were discussed in the last lecture to maintain the continuity. We started with the equality of vectors that when the two vectors are said to be equal, that is A is equal to B. Then we also cover the addition and the subtraction of the vectors, and you must remember that we cover the triangle law of addition and the parallelogram law of addition. In triangle law of addition, when the vectors A and B they are added graphically, and a triangle is formed, and in parallelogram method a parallelogram is formed, and we have seen that both of these methods they were equivalent. That is, the resultant vector R that was formed using A and B same vectors, the resultant vector R was also same. Then we discussed that subtraction, that is A minus B is equal to A plus minus B. Like we simply for subtracting A and B, we have to add A and minus B. Then we also covered the vector addition, that is analytical method, where we had written, let me just show you, for the vector addition using the analytical method, we have seen that A bar was equal to AX I cap plus AY j cap, and B bar was equal to BX I cap plus BY j cap. And when we simply add these vectors, we can directly get AX BX I cap plus AY BY j cap. Now this thing can be extended similarly to more number of vectors and even to the 3 dimensions case. Then we also covered vector multiplication in this case. Firstly, by when a vector is multiplied by a real number lambda, which can either be positive or it can either be negative, how the result would differ. And then we have seen that vector multiplication by another vector is of two types. It is of two types. The first one is known as the dot product or scalar product because it gives us a scalar result, and the second one is known as the cross product or the vector product. We had already discussed dot product in the last lecture completely, and we had seen the backend calculation that if we consider these two same vectors, that is A and B, and when we dot these vectors, how the backend calculation and the backend procedure, it gives us a resultant vector. And we had also seen that how we can dot the two vectors A and B easily. If A, and when we write A dot B, A dot B means we have to write A first and then B. So this was the result. Like we have to multiply both the numbers which are there with the I cap, and then we have to multiply both these numbers which are there with the j cap in the y direction components, and then we have to add these. So this was the trick involved behind this dot product. Now today we are going to discuss the cross product. Now this product is also known as a vector product because the result that we get of A cross B is a vector quantity. Now the one important thing to note here is that the cross product between the two vectors, it always gives us a vector which is perpendicular to both of these vectors. So as we had seen when we were discussing in a three-dimensional space, we said that, let me draw this. If this is y axis, this is x axis, then we said that in 3 dimensions there is one axis which is known as the z axis, the third axis, and it points either out of the screen of the laptop or it points inside of the screen. So basically this means that when a particular vector is perpendicular to both the vectors. Here, z-axis is perpendicular to both x-axis and y-axis. Similarly, the y-axis is perpendicular to both z-axis and the x-axis. So these three vectors, they are said to be perpendicular to each other. Now, the other thing is, uh, for this, for the cross product rule, we must always remember that it is not possible in two dimensions because the resultant vector is always going to be in a third dimensional, in the third dimension. So this cross product concept is only applicable for the three dimensions and more. So we are going to discuss this. First, as we discussed about the dot product, we first discussed the rules of the dot product with the using the unit vectors. So here also we are going to discuss the rules. So first rule says if the unit vectors are I, j and k, then I cross I will always be 0. Similarly, j cross j will also be 0 and k cross k will also be 0. Then I cross j will be 1. Let me put a cap here simply to denote the unit vectors. Then j dot k will also be 1 and k cross I will also be 1. Third rule says just the opposite, that is j cross I will be -1, k cross j will be -1, I cross k will also be -1. So to remember these rules, you don't have to just learn them. It's a simple trick that when the two vectors, when the two unit vectors, when the two same unit vectors are crossed, then it is always 0. When the two different unit vectors are crossed, the result will either be 1 and -1, and that will depend upon this diagram. Uh, so this diagram you can remember. We are going from I to j, j to k, and k to I. So basically, if we follow this direction, we will always get a positive 1, that is +1. So you can say I cross j is 1, j cross k is 1, k cross I is 1. And if we follow the opposite direction, that is if we go this way, we will get a negative. And here we will get a positive. So you can check our rules. They are matching with this scheme. So you can remember it this way. Now let us do the backend calculation as we did for the dot product. Let's first write A cross B so that there is no confusion. And when we write A cross B, we will simply cross this, and as in ordinary algebra, we cross when we multiply two expressions, we first take this first term in the expression and then multiply it with all the other three terms in the second expression. Similarly, we are going to do it here. Let me show you. First, we will take A1 and we will multiply it with this. So we will get, this will be a lengthy. So as we are doing the cross, so we will put cross between the unit vectors I cross I. Then we will take A1 and B2. So it is I cross J. You have to remember here that the order in which we are writing the vectors here is very important. Because if we are writing A cross B, so we need to take A first and then B. So we will write first A here, the unit vector corresponding to A first, and then the unit vector corresponding to B. So the order here is very important. Then we will take A1, B3, it is I cross K. Then we will take A2 and we will write all the terms A2, B1. So we will J cross I. Then we will take A2, B2, J cross J. Then we will take A2, B3, J cross K. Then we will come to A3. We will take A3, B1. First is K, so K cross I. Then we will take A3, B2, A cross J, and the last term will come here, that is A3, B3. It's simple K cross K. And then we have to do nothing. We simply have to put the values from the given rules above. So as I cross I is 0, so it will be 0. I cross J is 1, it will be A1, B2. I cross K is minus 1, it will be minus A1, B3. Oh, sorry. We don't. We have to put here the vector, the unit vector also, because that's very important. So it's a multiplication of the. So in the second term it is I cross J, so we will get यहाँ पे K. In the third term it's I cross K, so we will get minus J. Then we will get A2 B1 minus K. Then we will get A2 B3 plus I. We'll get A3 V1 plus J. Then we will get A3 V2 minus I. And this last term K cross K will again be 0. So we can sum this up. We can take the terms with the I cap together. So we can say this here is I cap and this is I cap. So we will write similarly, taking the negative or the positive sign into consideration. So the result would be A2 B3 minus A2 A3 B2 with I cap, then minus A1 B3 minus B1 A3 J cap, and thus we will have A1 B2 minus B1 A2 K cap. So this is our final result. This is our final result. So this was the backend calculation for A cross B. And similarly here also we will discuss a trick to solve the question in less time and in an easy way, because for the complex calculations, if you start doing this backend calculation, then you will take a lot of time. So let's go to this. We'll take a new slide, and so first write down the vectors again. A is A1I, A2J, A3K. V is B1I, V2J, B3K. And so the trick here is first we will write in the first, we will create a matrix or a determinant type of thing, as you must have studied in your mathematics course. So in the first row we will write ijk, that are unit vectors, and then if we want to calculate A cross B, that is first is A, so we will write the first row, the second row containing A1, A2, A3. Then we will write the third row containing the B1, B2, B3. Then see, what we will do here is first we will write this I, then we will neglect the A1. We will neglect the elements below I here, that is A1 and B1 is neglected. And then we will multiply this, like as in matrices you see, we when we find out the determinant of any matrix, we do the similar things. So here also we will do A2 B3, first A2 B3 and then minus A3 B2. A2 B3 minus A3 B2. Then when we take J, we will take a minus J. We will neglect this A2 B2 because it's below J, so we will neglect it. We are left over with this column and with this column. We will multiply this. That is, it will come A1 B3 minus B1 E3. Similarly, when we will take K, we will again take plus K. These are all the unit vectors. Even if I forget to put this cap, it is always understood that we are taking here the unit vectors. So when we talk about K, we see that we will neglect this A3, B3. So we are only left with these two columns. So here also we will get A1, B2 minus B1, A2. So this is our, let me write this. It is A cross B. So this is the final result. You can check this, you can match this result with that result of the backend calculation. It is exactly the same. We must always remember that I is taken to be positive here, and when we write J, we put this negative sign. So many students they might make a mistake here. So you should always remember that I is positive, J is negative, and again K is positive. So this was the trick which is involved with the cross product. Now we are going to use these concepts for the motion in a plane. So when an object moves on a plane, we need certain quantities to define its motion. The very basic quantities include its position vector, its displacement vector, its velocity vector, its acceleration vector. These are some of the basic quantities that are needed to define its motion. So we are going to start now the position vector and the displacement vector, and we'll see that how we can move to the velocity and acceleration part. So we have already discussed position vector and the displacement vector, but I can give you a brief idea again about it and write it in the mathematical form, because we are going to derive velocity and acceleration in mathematical form. So let's say this was our plane, x axis and y axis, and suppose the some particle is there and it's moving in this path, and we say at some time t the particle here is at p, and at some another point it is at this point p dash. So at so initially at some time t it was at p here, and then it was at p dash, suppose say after 5 seconds. So this was the path. So these two, this OP and OP dash, they are the position vectors, and PP dash is the displacement vector, as we had already discussed in the first lecture. So this PP dash vector is the displacement vector. Now, with the thing here we should remember is that if suppose we are talking about P, so the position vector which is related to P will be xi cap plus yj cap. Now, when we are talking about P dash, so let's say the position vector of the particle at P dash is x dash I cap plus y dash j cap. And when we want to calculate the displacement vector, we know that we have to simply write it in the form displacement vector will be final vector minus initial vector. We also did a question regarding this. So you must know this, r prime minus r. So here when we'll subtract it, we'll get x prime I plus y prime j minus xi plus yj. And we subtract it, we will get x prime minus x I cap plus y prime minus y j cap. So this thing is known as delta x, and this thing is known as delta y. That is the change in x and the change in y. So this is how we write a displacement vector for the motion in a plane. Now we'll go on to velocity, and we'll see how to define velocity. So first, look at the average velocity. So the average velocity of an object is simply the ratio of the displacement and the time interval So average velocity, we can write it as, in simple mathematical terms, delta r by delta t. Delta r here is just we discussed was the change in the displacement vector. The delta r is a displacement vector and r is the position vector. So delta r is simply we can write it when we break it. It will be delta x by delta t I cap plus delta y by delta t j cap, and we can write it as vx I cap plus vy j cap. That is this delta x by delta t as vx and delta y by delta t as vy. So we get the velocity vector. This is the velocity vector. So the direction of the velocity vector we see is exactly the same as the direction of the displacement vector, because we have simply divided the time duration from the component. So the direction is the same. And when we talk about the instantaneous velocity, so this is the average velocity of the particle when it moves from P to P dash, in the diagram we discussed. And when we are going to talk about instantaneous velocity, that is the limiting value of the average velocity as the time interval approaches zero. So in mathematical terms, we can write it as limit, because as a limiting value. So we will take delta t tending to zero. Delta t here is very small. Here it's delta r by delta t. And we'll again open this similarly as the above. When we'll open this, we will get delta limit delta t tending to zero, delta x by delta t I cap is delta y by delta t j cap. And when we'll put this limit over this delta x by delta t, we know that when delta t will be very small, we can put it as dx by dt I cap plus dy by dt j cap, or in simple terms we can simply write dr by dt. So this is the instantaneous velocity. Now I will use a figure to explain what this exactly this instantaneous velocity means. Is suppose we discuss that a particle is following this path, and our initial point was P, and this was P dash. And this suppose, because we want to say that delta t is decreasing because it's tending to zero, so it is decreasing. So we will say that now we will discuss when the particle is itself at position. This displacement vector from P to P1 would be this. When the particle is here, say at P2, the displacement vector would be this. And when we keep on decreasing this delta t, that is, let's suppose delta t is very, very small, or it's say 0.1. So the particle will move from here to here. Or we can say if it is even small, that is 0.01 seconds, then we can say that the particle has moved a very little bit from here, from P. So when we draw the displacement vector, it is simply the tangent at this point. Let me draw this first. This is the direction for the displacement vector in this case. So as we see that as delta t is tending to 0, V average is tending to, as delta t is tending to 0, V average, that is average velocity, is tending to instantaneous velocity. So this is the concept behind the instantaneous case. This direction of the instantaneous velocity is always a tangent to the path at that point, at whatever point we want to calculate the instantaneous velocity. So suppose if this is some arbitrary path, we want to calculate the velocity here, instantaneous velocity here. So the instantaneous velocity will be in this direction. If we want to calculate the instantaneous velocity here, it would be in this direction, because this is the direction of the tangent to that particular point. The direction of velocity at any point on the path of an object is tangential to the path at that point in the direction of motion. And if we want to calculate the direction and the magnitude of velocity vector, we can simply do it because we have already discussed this in the last lecture. Now, this was the concept of velocity. Similarly, we will also write the acceleration vector. Now, coming to the acceleration vector. So average acceleration, as we had seen average velocity first, so we will see average acceleration. Average acceleration of an object for some time delta t is the change in its velocity divided by that time interval. So average acceleration in mathematical terms, it can be written as delta v by delta t. Or when we'll expand, it will get delta v by delta t. Sorry, this is x because we are expanding it in the components. So it's delta Vy by delta T j, or we can write it as Axi plus Ay j. That's the component of acceleration in the x direction, and that's the component of acceleration in the y direction. So acceleration can be written in this way. So as we just went through the concept of instantaneous velocity. Here also we'll go to the concept of instantaneous acceleration. So instantaneous acceleration is the limiting value of average acceleration, and when the time interval is tending to 0. So when we talk about instantaneous acceleration, we will write A is limit delta t tending to 0, delta V by delta t, and when we'll expand this, we get dvx by dt I cap and dvy by dt j cap. This can be written, this term can be written as ax, this term can be written as ay. So that's the instantaneous acceleration at any point. Instantaneous simply means that we want to calculate the acceleration at a particular point only. So as we saw that when we were changing the position of the particle, the direction of the displacement vector was changing. Similarly, the direction of the velocity vector will also change. And that's why the direction of average acceleration will also change. But the direction of average acceleration is same as the direction of delta V, because see this average acceleration, and that is written as delta V by delta t directly. So both these directions will be same. But if we so the direction of delta V would be, suppose if this is the plane and our particle is moving somewhat this way. So suppose initially it was here, so the velocity vector would be this, and somewhere here the velocity vector would be this. So this is initial, this is v, and this is v prime. So if we want to see the direction of delta v is simply the resultant. Matlab delta v will be written as v dash minus v. So we can simply calculate this using the triangle law or the parallelogram law. So what we did was v dash is this plus of minus v. So minus v will be in this direction. So we will, this is minus v, this is v dash, and then we will simply join these two. Sorry. We will simply join these two and we will get the velocity vector. So this is the delta v vector. So this is the direction of delta v, and the same will be with the direction for the average acceleration. So as delta t is tending to 0, acceleration average will be tending to acceleration instantaneous. So this we have seen that how can we calculate the average acceleration mathematically and the instantaneous acceleration mathematically. This will be very helpful in deriving the formulas which are related to motion in a plane. Now we'll stop here. for this theoretical part, and we will again discuss some questions as we always do at the end of that class. So our first question here is, rain is falling vertically with a speed of 35 meter per second, and wind starts blowing with a speed of 12 meter per second in east to west direction. So the question is, in which direction should a boy hold his umbrella so that he doesn't get wet? So in such questions, you should always remember that first we should draw a vector diagram so that we are not getting into any confusion. So first, it's given that the rain is falling vertically with 35 meter per second. That is, this is VR. It's 35. Then the wind is flowing from the east to west direction. That is, wind is flowing in this from east to west. Is this direction? It is 12 given. It does denote this with VW, and in which direction should a boy waiting should hold his umbrella? That simply means that the wind will cause the raindrops to move slightly or change their direction. So in which direction should a boy hold his umbrella? The umbrella should be held in the direction of the resultant vector. Only then the boy will not get wet. That is, the resultant will be somewhere in between both these vectors. Let's suppose this is the resultant vector R, and we already know the formulas that how to calculate a resultant vector. It is always equal to VR square plus VW square, and we'll put the values. We will get 35 square plus 12 square, and we will get 7 meter per second. And for calculating the direction, we get the y by x. Here that would be tan inverse of 0.343. It will come out to be 19 degree approx. So basically, let's see if this boy is standing this way and he has an umbrella in his hand. So if this is the umbrella, and if he holds this umbrella vertically, but we will see that what is the direction of the resultant? It's this way. So he will simply get, if the rain is coming in this direction, he may get wet. But if the boy is standing here, and if he is holding umbrella in this direction, let's see this umbrella, and he is holding the umbrella in this direction or the direction of this resultant vector, then he will not get wet. So this was the question. Let's now move on to the another question. We also discussed in the last lecture a question which was about the commutative law and the associative law. So here also we are going to do the same, but not for the dot product. It would be here for the cross product. So basically we have to verify the commutative and associative law for the cross product. So coming to the commutative law first. And let's suppose vector E is A1I plus A2J plus A3K, and vector B is B1I plus B2J plus B3K. And if we want, we will first calculate A cross B. So we will write I, J, K, A1, A2, A3, B1, B2, B3. And what we will do here is we will write I, we neglect this row, A2, B3 minus A3 B2. Then we will write minus J, neglect this row, A1 B3 minus A3 B1. And then we will write plus K will neglect this, it will come A1 B2 minus A2 B1. Now in this side of the screen, we will calculate B cross A. IJK, so we will write B first. So we will write B1, B2, B3 because B is first written, then A1, A2, A3. And then we will calculate this. We will write I similarly. We will write B2, A3 minus B3, A2. We will write minus J. We will write B1, A3 minus B3, A1. We will write plus K, neglect this, B1, A2 minus B2, A1. Now let's compare what are the results. Like with I, we will have B2, A3 minus, here it's positive A2, B3, here it's negative A2, B3, here it's minus A3, B2, it's plus A3, B2. When we go to the J component, we will get this J has this negative, if we take it inside, it's minus A1, B3. So it's plus A1, B3 with this negative. This has also the same reverse sign. And if and when we talk about the kth component, we will get this has plus A1 B2, this has minus A1 B2, this has minus, so this has plus. So we will see that the signs of all the terms in this expression are just the opposite. So seeing this on comparing, we can say that A cross B is equal to minus B cross A. So as a commutative law says that A cross B should be equal to B cross A, and this is not the case. So commutative law does not hold here. Now for the associative law, I want you all to derive the associative law, verify the associative law similarly as we have done this. So if you don't, in case you don't know what associative law is, so we can say, let me write this here. For the cross product, it would be A cross B cross C. This is the associative law. So first you will calculate this expression, the LHS expression, and then you will calculate the RHS expression and match the results. And if this expression is exactly equal, then the associative law holds, otherwise it does not. Now let's move on to another question. This question will be based on what we did today, that is velocity and the acceleration. So let's see like how to calculate the velocity and the acceleration. So the question is, position of the particle is given by, that's the position vector is given by 3t 2t square, and we have to calculate the first part is find velocity, that will be a function of time, and acceleration as a function of time for this particle. So here I can write the formulas. They are for velocity we had seen. Velocity as a function of time would be given by dr by dt. We have just derived it. And acceleration will be given by dv by dt. So we use these formulas only. So velocity is given by dr by dt. So dr, like the position vector is given, we simply have to do this, that d by dt of r, and r is 3t I cap 2t square j cap plus 5 k cap. And when we'll differentiate this with respect to time, we will see that this first, the x component, it comes out to be 3 I cap, and on differentiating this, we will get 4t j cap. So this is our velocity vector. Similarly, the acceleration vector, we will get 3v dv by dt. We will use d by dt, and we have just now calculated v, so it will be 3i plus 4tj. And when we'll differentiate, this will be 0 because this term has no t term here, and we will have 4j. Acceleration will be 4j. Also, the second part says find the magnitude and direction of the velocity at time 1 second. So the same formulas we are going to use for the magnitude. So the magnitude of v will simply be, because it has c square plus 40 whole square. Now here we have t at 1 second. The time is 1 second, so we will put t over here. So we will get 3 square plus 4 square, and the answer will be simply 5 meter per second. And for angle, we will take theta, it is tan inverse of 4 by 3, because t is 1. It will come out to be approximately 53 degree. So this was the how we use the velocity and the acceleration vectors in our when we study the motion of a object. I would also like to give one homework problem, or rather say 2 homework problems. So the first homework problem is find angle between the two vectors. Between vector A is I plus j, and vector B is I minus j. I will provide the hint over here that first draw the vector diagram, and then you will be able to understand that how you need to do this. And the second question here is homework problem, that I'm giving you certain quantities that are frequently used in this subject: temperature and area. What you have to do is classify these as scalar or the vector quantities. And then we'll discuss this in the next lecture. So we'll end this class today here only. And in the next class, we will discuss the motion in the plane with the derivations, which will involve the quantities like displacement of the object, the velocity, the acceleration. So we'll get certain formulas that we can use to find out the acceleration and the velocity of the particle in different cases. So we'll stop here. Thank you.